Pas là, sur la table. Non, Yvan, Yvan. Sur la table, sur la table.
Ça va, ça marche. Bonjour, hello, my name is Yvan Bull. I think you don't know me. I was in Sixth Wind for 10 years before, and I had a chance to work in the DPDK for some time. So I will introduce Thomas and Olivier from Mellanox and Sixth Wind to first speak about mbuf. mbuf, okay? That's the key of the DPDK. And the layout of mbuf, is that right?
Yeah.
Okay, so Olivier is one of the king of the mbuf. He knows everything about every field in the mbuf structure, where and which cache lines work, okay? So where is the size of set in the structure, you know it? Maybe not, okay? Well, anyway, I had good time working with Olivier, and let me say something. I think we should have a special prize named Olivier's Prize. And we would win this prize. People who could be able to make Olivier change his mind. So I give you that chance today, try. I was never successful to do that, okay? Thank you.
Thank you, Yvan. Hello.
Okay, hello. So now you know our name. So I'm Thomas Monjalon. He's Olivier Matz. He's working in Sixth Wind. I'm working in Mellanox. Okay, let's talk about mbuf. I need to click to pause the slide. So, first, why mbuf? We really need mbuf to offload a lot of things from our devices. This is the central place to put our features, our device features. For instance, for flow steering, you put some information, metadata for segmentation, checksum, classification. All these things take place in mbuf. But we also need mbuf if we want to offload some protocol processing, like IPsec, or if we want to do other cryptography, or even maybe for compression, and now we are going to add some pattern matching. All these protocol offloading can benefit of using mbuf fields. mbuf is a central structure of DPDK, and not that it can also be used by software if you implement this feature as a software fallback. So let's see exactly what is mbuf. The definition for mbuf could be it is the structure for metadata for a network packet, and more precisely for a packet segment. So you have one mbuf per segment. What is there? So you have the usual things for a packet, so the data, actually not the data itself, but the metadata. So the pointer to the data, the size for the data, even a pointer for external buffer, also information about some private data. I will come to it later. You have also all the information for the segment, its size, how many segments you have, etc. And then come the protocol metadata. So protocol can be, for instance, VLAN or IPsec. It is able to manage things for tunnels, for your checksums, describing which type of packet it is, how organize the different layers, L2, L3, even L4. We have also a lot of metadata for packet classification or flow classification, and more things like timestamping or metadata available for the application. And of course, the last one is offload flags. This is just a bitmap, just to say if the offload is enabled or not. Okay, we did not forget anything, Olivier?
No, I don't think so.
Yeah. So one more thing. All this metadata are used mainly by the device drivers. But if you want to add some metadata in the packet in your application without any interaction with the driver, you have another place to do that, which is called the private data space. Yeah. So you can see it here. It is a yellow thing.
It's optional.
It's optional. So by default, the size is 0. Yeah. It is not the headroom. Headroom is something else. Headroom is just the place before we start putting some data. So if you want to extend the data to add some headers, you can use this place. So this is really part of all these things are data. The private data size is just here, and you put your application information in each packet. Yeah, and it's configured when you configure the mempool, which is allocating the mbuf. So you just give the size you want to reserve, and all DPDK libraries drivers won't see it. It's just transparent. Now, let's talk about why we want to talk today about mbuf. Because if you want to talk about it, it's not because it's wonderful, that's right, but there are some limitations. First limitation, the most important one, mbuf is very small. This is, at the same time, it is a limitation, and it is a very good benefit, a very good design. Why it is? Because if you manage some small buffers, you avoid to have too many cache misses. If you avoid cache misses, you know you will get the best performance. So how small it is? We used to say we have 2 cache lines. If we count cache line as 64 bytes, which is very common, but you know there are some CPU architectures which use bigger cache lines, 128. So sometimes we say cache line, but the correct word is to say there are 2 parts. Actually, the first part is more dedicated to RX information, and second part is more for TX. It's another story. And so all this space is used. All but one small place at the end, which is only 16 bytes. So you see the total size on, for instance, on x86, the total size of mbuf is 128 bytes, and only 16 bytes are remaining. So when we are going to add new offloads, new features, and we will need to add new fields in mbuf, what will happen? Very soon we will just block. I don't want to be the fireman here, but we need to think about it. And first thing is that maybe there are some fields in the mbuf which are not so useful. But most important, if you don't use all the fields at the same time, when you use one application, you have one use case, and this use case is not using all offload capabilities of the mbuf. Okay? So let's say, for instance, we use only half of the mbuf, and the rest is just wasted. It is wasted memory. And some of them are not never used, but very rarely used. So these are the limitations, and but to better explain other limitation, because we don't have a lot of space, sometimes we allocate some space for some fields which is not well described. It happens. For instance, there is something called sequence number, but which sequence number we don't really know. Even metadata, okay, metadata, there will field metadata inside the metadata structure. Okay, interesting. So what is it? It can be used for many things, for application. There's even some user data. Again, this is just when we say user, this is application. So this is a field for application usage. There is also something called USR. From as far as I know, it's used only in distributor library, so but that's free to use. The problem is that if you don't describe precisely what is the definition of one field, some different application or different libraries can use it for different purposes, and that's okay. But if you use it for different purposes at the same time, there will be a clash. For now, as far as I know, we are avoiding this clash, but it's just by chance. And one more thing, this is done on purpose. Because we don't have a lot of space, we use 64-bit to put all these different features. Yes, yeah, we use, the union in C code to put different features at the same place. So what does it mean? It means if you want to use RSS, you cannot use at the same time the TX metadata because it's at the same place. So the features are mutually exclusive. I think it's clear enough that this is a bad situation. So there is one more, I would not say it's a limitation, but something we must take care. We really want to improve the stability of the ABI and API in DPDK. And the problem is that if we need to move a field in mbuf or remove one field for any reason, because we lack some space, then we will break everything. We will break every application. At least you'll need to recompile your application. At worst, you'll need to change how you access some field. And even worse, if you have a driver, if you're using a driver like some vector drivers, which are very well optimized for the current layout of mbuf, you will need to redevelop this driver because you change the layout. So what does it mean? It means that we don't want to change mbuf. It's a too much strong breakage, but sometimes we need to do it. But the target for the future is not to change it, never. So maybe we'll need to do some few changes to make it future-proof, and after, don't touch anymore. Of course, that's the promise. So that's a very big problem that other projects have. For instance, if you follow what is said currently in the line scanner community, especially in XDP, they are wondering how they want to manage metadata. And there is another example of such design. It is in FreeBSD. They implemented it for years, and it is called mtags. But I will let Olivier talk about it.
Thank you, Thomas. Bonjour. So why not reuse the same approach than FreeBSD mtags? Because it is a flexible approach. You can register a space of any size that can be attached to mbuf. It is allocated and chained to the mbuf. It's flexible, but it has some performance impact because you have to allocate each mtag and attach it and chain it to the mbuf, which means when you free the mbuf, you have to free all the tags that are attached to this mbuf. It has another drawback, it is a cache locality. When you access to the tag, it is not the same place than the static field of the mbuf, which means you have to fetch it in the cache first. So if you have several several mtags, it is at different place, so it will impact performance. Another problem is you have to allocate and free this mtag, so you need pools. You need maybe to have them per NUMA node, or you can reuse mbuf pools, but in this case it will be a very big object for maybe small data. You have problem of dimensioning, and all this problem will have to be managed at application level. and so it will add complexity. So maybe it's not a satisfying solution for DPDK. Another question is why not just increasing the size of the mbuf? So Thomas said the current size of the mbuf is 128 bytes. Why not add another cache line? It's simple, but for the same reason of cache locality. If you add another cache line and you want to add a specific field that is filled as in the Rx part of the driver, you will have a cache miss and you have to wait and you will lose performance. Also, it won't solve the problem that was described by Thomas about the ABI breakage when you change the layout of the mbuf. And finally, it does not solve the other problem that was described before about the space which is wasted when you don't use a field and you have it anyway in the structure. It's wasted space. Another approach that was evoked is a selective layout, which means why not having different layouts of mbuf and the application choose which one to use depending on the use case. So this would require as many structures as use case. For instance, one will want a timestamp plus user metadata. The other one will want sequence number plus IPsec offload, and so it's not manageable to have this in the driver. We'll have to handle all the different layouts, and it seems not doable. So here comes the proposal I have made in July as a RRC patch. I have updated it yesterday and I addressed the comments that was made on the mailing list. So the concept is to register fields in mbuf structure dynamically, on demand, and depending on the use case. Which means if the application wants to use a timestamp in the mbuf, it explicitly asks for it. And the API here is you ask for a name, so timestamp, size 64 bits, alignment, so at the 64 bits boundary, and flags. So for now, flags are unused, but in the future, we can imagine to ask to have a field specifically in the Rx part or in the TX part, depending on what you want to do. And it returns you an offset in the mbuf structure, which is the place where the field will be registered. So when an application wants to use, let's say, a timestamp, it will ask the PMD to activate this offload through the ETH-dev API. So, and the PMD will register this field. And after, the application and the PMD can access to it. It will have a small performance impact, but an impact, because instead of accessing an address, the mbuf address plus hard-coded offset, we'll have to access to the mbuf address plus a dynamic offset, which will be in a variable. This registration of a dynamic field is system-wide. It impacts all the mbuf in all mbuf field in all mbuf pool. Sorry. This is to avoid to have incompatible mbuf. If you take a mbuf from a pool A, it will be compatible with a mbuf from pool B. It is simpler to manage. And we have the same logic also for dynamic flags. Because usually when you need a field in the mbuf, there is often an associated flag to say if the field is valid in the mbuf or not. So there is the same API for dynamic flag. You register by its name, you pass flag or a count of flags, and it returns you a bit number in the offload flag. So this is the API. For each dynamic field, you will have to describe its name, the size, the alignment, the flags. To register, there is a function. It returns you the offset in the mbuf structure. and you pass the descriptor, the parameters of this dynamic flag, this function will be called by the PMD or the application or boss. I mean, if you register a field once, if you call it again with the same parameters, the same offset is returned. And to access to the field, there is a macro which uses the mbuf and the offset that was returned but at registration time. And there is a similar API for the flags, of course. On top of this base API, we can add helpers. For instance, for the timestamp, we will need to register a flag and a field. So we'll introduce a function to register both at the same time, and accessor, which will be used in the data plane to set the timestamp, to check the flag if the timestamp is present or not in the mbuf. And one is missing about deleting also the timestamp. So what are the drawbacks and limitations of this proposal? So as I said, there is a performance impact, which is, I think, quite small and acceptable for some use cases. I've made a quick benchmark and compared it to the access with a static field, and it's a couple of cycles longer, but it's not that much. One other limitation is, as of today, in the API, you cannot unregister dynamic fields. So what you cannot do is having an application which registers fields for a use case. You forward packets, you do your stuff, then you want to stop all and unregister fields and register for another use case. So this is impossible today because it's quite complex to be sure that all mbufs are unused. And the last limitation is, of course, there is no magic. You cannot register more than available space. Today we have 16 bytes. Thomas said it. You cannot register more than 16 bytes of a dynamic field.
Yes, but we can try to get more space, maybe. I will talk a bit about it, but I will try to be fast because I'm sure you have some questions about this big change. So, what is the plan? The plan is just to get more space. Why? Because this new change can be sustainable for future, for forever, if we have enough space for all the features we want to enable at the same time. So, in order to achieve that, we need to move some fields from static to dynamic. So I just want to discuss which one maybe can be moved. And one thing interesting to note is that if a field is used during the receiving processing, during RX, and if it is not in the first part of mbuf, you may need to you will have a cache miss to just get the second part of the mbuf, so you decrease the performance of RX. It's better to have all RX fields in the same part of mbuf, which is the first one. So maybe if we get some space in the first part, which is totally full today, if we can get some space in the first part, we can improve the performance of these features. And later then the flags for registering a dynamic field will tell your preference if you prefer to get this field in first or second half of the mbuf. Okay, what is the candidate to move a field from static to dynamic? At first, it should be a field which is not used so often, or it can be a field which is very vendor-specific. With this new change, it is more allowed to have vendor-specific fields. So that's another improvement. But as Olivier said, there is maybe few cycles wasted to access this field. So if you are really critical for 2 or 3 cycles, maybe you're not candidate. And of course, all the fields, you remember the figure with all the fields which are union in the same 64 bits, they are of course candidate to move. It can stay as that. So which one? From there is a user data field. This one is just for application. There is no need to get it every time in mbuf. When application needs such field, it can allocate some and better define how to use this field, and the application can use more fields for its own use than the one we have today. There is another one which is defined as a user field, USR. I already talked about it. For now, it's just for distributor. Probably it can be moved. Maybe some people will propose to move the pointer to the external buffer metadata. Actually, it's not so easy to move because external buffer, it's part of mbuf API. So probably better to keep it as is. There is also a field for PTP. I don't know if everybody knows what is PTP. This is standardized as IEEE 1588. And this is a payload which is in a UDP packet. And for a long time ago, we introduced some fields in DPDK for this thing. This is something to discuss. Honestly, I'm not sure to understand why we need it in mbuf, but we can discuss it later. There is a field for timestamp. So it is just to get the timestamp of the packet, when you received it. The device is able to write it in the mbuf, so you can get it in the application. The thing is that this field is the one field which is in Rx part, but maybe not widely used. So if we can move it, we will gain 64 bits in the Rx part of mbuf. There is a sequence number. Is TCP sequence number, IPsec, I don't know. It's not really well defined. It is used for reordering packets, of course. Who is using it? Not sure. We need to discuss. There is something about QoS, hierarchical scheduler. This one is in the big union with RSS and other flow steering metadata. So probably it should not stay here. And anyway, QoS is not a feature used by all applications, so it's a candidate. One more, there is a field for event dev for TX adapter. This is one more in the big union, so it should not stay here. And one more union, the metadata, already talked about it. Anyway, there are some patches in the air about metadata currently. These patches are worked by Mellanox, so we'll see how we change the layout. We can discuss more fields if you want. I guess there will be some hot discussion on the mailing list on this topic. Anyway, every time we will move a field, it will be an ABI breakage, and we want to avoid ABI breakage now. So probably we will have some small windows to open API breakage, maybe one window per year or even less. We'll discuss it this afternoon. So each time we will have an ABI breakage window, we should take this opportunity to clean the mbuf and get more space. Time for conclusion. First part is for you, Olivier. You already sent yesterday your patch.
An updated version, so if you have any feedback, please let me know.
Of course, so this is a target for to be merged now in this release 1911. And then when we will have this new big change, big feature, we will be able to get more space by moving some fields, but I propose to start moving fields for the next ABI breakage, which may be in 2011, in 1 year. Yeah, so we have 1 year to think about it, to prepare it, and make it very clean. Okay, questions? Okay, there are a lot of questions. Stephen, first. You will get a mic for a question. Yeah.
This is on. There we go. It seems to me that a good candidate would be to have two splits, a split of this so that you could ask for fields in the system data and ask for fields in the user data, which would be in the private area, so that applications that wanted to manage using the private data could use these routines to manage their own fields in the private data reserved area, and you could also use the same code to manage fields in the mbuf area.
Yes. So the current patch does that, but this is something we have to think about.
That way you could say you don't need the user data in the system area if you want to reserve or manage your own private data area. You could do something. Right now it's kind of a free-for-all. We just give it to the application and it has to figure it out. We don't really give them any help.
Yes, I agree. It's a good idea. There's one problem because the private data for now is per mempool, and this is system-wide. So we have to think about it, but I think it will be a good idea to have the same API for private application data, but it's more complex than just.
Okay, Alex, please. No, okay, Mike is going to somewhere else.
Hey.
Constantine, yes,
Yeah,
please.
just a quick one. So I see there is dynamic API. Would it be ability to define these fields statically? Because if you have one app and you register same fields always, it's no point them to be dynamic, right?
Sorry?
You say if we are using a field
Okay,
always?
but,
it should
there
be
is an
dynamic.
API to define fields dynamically, right? So at startup, the user have to decide what he wants to use and decide I want to use timestamp, whatever, right?
Yes.
In theory, you can decide then when you're building your application, right? In that case, you don't need to do it dynamically and it's supposed to be a bit faster. So would be there sort of a way, an API to define these fields and access these fields in a static manner. So the compiler can do its optimization job.
It's a good question.
Frank is saying it is breaking the API. The API.
Well, you're breaking API
Every,
anyway.
every time you change the
No, you
mbuf,
don't. You don't. Well, okay. It would still be a macro, right? You would still have an offset,
No, the
and you would
yeah.
access this field by offset, but you would know offset not at runtime, but at building time,
Okay,
which would save you cycles, right?
yeah, for sure. This is a good optimization. So I will take the red hat to talk about the ABI stability. When Red Hat or other distribution are packaging DPDK, they are packaging it without knowing which application will use it. This is a shared library. So you cannot optimize for a specific application.
Hold on, how it differs? Let's say I define it dynamically. They can't test each combination I could define dynamically anyway, right? So
Please repeat.
Yeah, you mean if you have your own version of DPDK which is compiled statically with your application, can you use a static field in that case?
So, okay. Question taken.
I think we could.
will continue. There are more questions, so I would just want to, please, Alex, here.
Thank you. So most drivers, or some of them at least, have vectorized operations, and these are matching a combination from hardware to mbuf descriptors, and doing it with offsets is probably going to break a lot of them, or very complicated pre-definitions of some sort. And maybe another second question, can the PMD register a dynamic field if it needs to use some offset?
Yes, so for vectorized driver, for now, they don't support a lot of features. So most of, maybe all features that are used by vectorized driver will stay static. It's data, length, etc. So the core of mbuf structure will stay static, of course. So I think it won't impact vectorized driver. For the second question, already forgot it. Yes, yeah. Yes. Usually it will be the case for an offload feature because the application will ask for an offload feature, a timestamp, I don't know, anything that can use a dynamic field. And when the application through the ETH-dev API will register this offload feature, the PMD will register the dynamic field. And if it is requested to many ports, never mind. It will be registered several times, but the same offset will be returned each time, so there's no conflict. And if the application wants to use the offset, the application can also register it again and get the offset, and so. Yeah.
So just to repeat it, the same field can be registered several times. You will get the same offset every time. That's safe. Yes, question here. 2 questions. Can we have the mic, please? Sorry, first one.
Okay, I would like to address the question about the vector implementation. So I think there could be some middle ground between totally static and totally dynamic. So if it could be possible to guess or be able to make it so that the offset is predictable somehow. If you have like a free fields, you could probably predict what offset would you use, and then the vector implementation could use that information to be quicker, or even the non-vector implementation would be easier because you wouldn't have to iterate over the metadata to guess what field you have and what field you don't have. So that would impact also non-vector implementations as well.
Yeah, but using dynamic field in a vectorized implementation, it's not impossible. It is possible to get the value and use vectorized instructions. It will be a bit slower, of course. And I think for all the parts that is vectorized, it's already very optimized. So I'm not sure the vector driver will use extended features that will be in dynamic field, but maybe in the future, I don't know. But not, I think not in the next year, for sure.
No question? The mic is always open.
Okay. I'm talking as a application developer. I'm welcoming this API that is dynamic because we have a nightmare of static linking. Someone is saying that it's not be necessarily dynamic, but for the static linking, my application needs to be a kind of variation of the static links, like with the Mellanox driver, without the Mellanox driver, and so on. So, and there is another, kernel drivers that we need to, adjust in the kernel versions. So, dynamic API is very good thing, I think, for the application developers. And one more thing I would like to comment is that private application specific data, we kind of like cannot use those data because it's gonna be too dynamic. I mean, it is in the 16 version, but when I upgrade to the 18 version, it's gonna go on, So
it's an API breakage.
Yeah.
Yeah, you have to deal with it.
Yeah. So yeah. So my code is going to be a kind of if defs, like the DPDK is above this version and below that.
Yeah, that's why we
mine,
don't want to do more API breakage, because the application is cluttered with a lot of if def. But let's agree that it's a last change.
But I noticed there are many wasted fields. So let's fix the API first, whether it's gonna change or not. But let's make the change less frequently.
Yeah.
And then with the dynamic API, it's gonna be a better world for me, at least. Yeah.
Come on, God. Thank you. Ferro, you wanted to ask something? Mike?
Hi. There were some performance numbers. What was they exactly?
So I modified the E40E driver. So it was not the vectorized function because it's for dynamic extended features. So I used the standard ones. I compared. I modified the sequence number field static and read it in my application. So my application, it's a 6-win get. And I get the numbers, and after I change to use a dynamic field and get the numbers.
So it consists data paths impact
Yes.
as well. But it will get worse when you have more dynamic fields, right? Because driver needs to add more check in what field it is. If it knows the change field, that is easier. But if driver doesn't know, and there are multiple options that can be,
Yes.
there
It's
will be
per
more
field.
check,
Yeah.
and there will
This
be
is few
more
cycles
feedback.
per field.
Yes.
Anyway, you are encouraged to test the patches that Olivier sent yesterday, just on time.
Yes.
So do your own benchmark, and please give some
Yeah,
feedback.
the problem, you cannot do the benchmark with the patch. It's just an API.
No,
So-
but we have one patch which can use it, which is not fully ready, but the metadata patch is going to use it.
Okay, thanks. One more
One
comment.
more question?
So this will break portability a little because some drivers will support some dynamic features, but others, right? So your application needs to kind of know which driver is working with. Because if you need that specific field, it needs to be supported by driver.
Yes.
If a driver is not supporting, and
Yes.
if you needed it, you can run it.
So-
So that because of that, I agree with Steven to use private area perhaps can fit better.
But at the time, we will use, let's say, I don't know, but if we convert, for instance, the timestamp, we'll have to convert all the drivers that use the timestamp to use the dynamic field. But I don't know if there is a lot of drivers for this case, or same for PTP or for user metadata.
Yes, it's all drivers or nothing. Yes, Bruce.
Just
excuse me, just to comment, we are very late. It's okay because the next talk is mine and I can be very quick. And this topic is very important, so let's ask the question, but let's try to be quick.
Just a quick one on, I haven't, to my shame, looked at your patch set yet, Olivier. But am I right in thinking that the first step is just adding like the macros for the dynamic fields without actually removing anything? So that wouldn't be an ABI break in itself?
No, there's
Okay.
no.
So even though, yes, you say you're targeting 1911, but if we have an, fixed ABI, it can still go into a 2005 release without breaking
Yes.
anything? Okay, just to check that.
Maybe last one.
I have a question and a comment. So, first of all, I think it's a great idea.
Thank you.
My question is it the intent that only the application can request fields, dynamic fields in the mbuf, or is it the intent that PMDs can request on their own needs? Or I'm writing a PMD, for instance, and I like this field. It's important for me. Is it the intention that the PMD can create fields?
Can you take an example, maybe, to better explain with a library?
Yes. So anyone, any the application, a driver, a library can register a dynamic field. It can be private to an application. For instance, if your stack requires to mark packets with a tag, the application can register a dynamic field just for its own usage. Similarly, a library, which I don't know, maybe the sequence number is only for libraries, I'm not sure, but so
No. The distributor one is a good example.
yeah, so a library can register a dynamic field which won't be used by a PMD or by the application. So it's free. But there will be also a dynamic field that are for all DPDKs that will be used by PMDs, libraries, and application. So
The idea is to build some feature-specific API on top of it. So for some feature, the application just need to know I really need this field. But in general, let's say, for instance, I'm using IPsec library. So you initialize the IPsec library anywhere. And during this initialization, the library can register the field for you. So it's transparent for you. You just initialize IPsec and it's ready. You will get the IPsec fields in mbuf. Is it better? More clear?
So the comment is maybe you should consider some sort of registry for these fields or field names, so different PMDs will use the same name and the same value and same size and everything for the same purposes.
Yes, it will be part of the mbuf API. We will have some reserved names.
Yeah, that would be well defined and agreed on.
It will be well defined.
Okay, great, thanks.
Okay, I would like to switch to the next talk. Maybe Constantine, you have one last question, the very last? Very last, Constantine, because it's you. Okay, raise your hand, please. Please, the mic to Constantine in blue shirt.
Well, just one quick question, just a thought. But does it mean that performance now become undeterministic? Let's say it depends even on order how you register your dynamic fields, right? And
okay, got it. Olivier.
We anticipated this question. So the current state of the patch set is the registration of the field is simple, which means, as you said, depending on the order of registration, you may even have, if you register a 16-bit field first and then after 64-bit, it can fail and success in the other order because it's simple. Next step is to choose the smallest available space, so it will solve a part of the problem. And after, that's right. If you register, if any libraries, all libraries want to have their room in the RX part of the mbuf, and there is not enough room, there's no solution. As I said, there's no magic. We have some space, and we use it. We use what we have.
We need some artificial intelligence to better feed the field, so we do a request to the cloud about how to locate them.
No, but that can be an issue, but I think the initialization is usually linear. It's not multi-threaded. There's no, so I think
usually, yeah, agree, it is linear, but again, yeah, things could change, right? And again, imagine you test with loading, let's say, one driver and user doesn't load that driver or load some other driver before that driver, right? And
I think, imagine you have you request for something in the RX part, then another one request in the RX part, and there is no more room. So you have the choice: either you can fail, or you can log with an error level. Or so if you really request to have it in the RX part, you can just fail if it's not available.
Okay, thank you. I suggest to continue the discussion on the mailing list, please, because we are very, very late. And I suppose you want to have some breaks today? Yeah? Okay. Thank you.
Merci.
Thank